Electricity powers our smartphones, the internet, and fills the world with artificial sound and light. But what exactly is it? In order to understand electricity, we first need to go over three important quantities which physicists are interested in: current, voltage, and resistance. We will cover these in this video. Simply put, electricity is the flow of charged particles, like electrons, which are negatively charged, or ions, which can be either negatively or positively charged. This flow of charge is known as a current, which is measured in amperes, after André Marie Ampère, an 18th century French physicist. So if we have moving charged particles, we have a current, and so we have electricity. Electrons have a really small charge, and there are so many of them. So we use the unit ampere for convenience. Charge is measured in coulombs, and 1 amp is 1 coulomb passing through a point in a circuit per second. As you can see, charge, current, and time are all related, and in physics, related things have equations. Since current is charge divided by time, we can write I equals Q over T, where current is I, charge is Q, and time is T. Charge is measured in coulombs, time in seconds, and charge in amps, where 1 amp is 1 coulomb per second. We can rearrange this equation so that Q is the subject, and we get Q equals I times T, which says that the amount of charge transferred, or the amount of charge that passes through a point, is equal to the current of the circuit multiplied by the duration of time that the current was flowing. You will need to practice using this equation, so here's an example question. Suppose you had an iPhone plugged into a 2 amp charger, and it takes 2 hours for the iPhone to charge fully. What is the total charge transferred to the phone? Give your answer in coulombs. Feel free to pause the video and attempt the question. If you got 14,000 coulombs as your answer, you're correct. If you got something else, that's fine, don't worry. The correct working out is displayed below. Electrons won't spontaneously flow around a circuit. We need to give them energy to push them from one side of the circuit to the other. This energy is known as a voltage, or a potential difference. The voltage in a circuit is similar to water pressure in a pipe. If the water pressure is high, then more water will flow through the pipe. And in a circuit, if the voltage is increased, the current will increase too. The reason we sometimes call it a potential difference is because it's the difference in energy at one point in the circuit to another. So far we've referred to voltage as an energy, and this is okay for helping us understand the quantity, but really it is the energy per coulomb, or energy per electron. Voltage is measured in volts, where 1 volt is equal to 1 joule per coulomb, or the electrical energy divided by the charge. The voltage is usually supplied by the power source. In a circuit, this is usually the batteries or the cells. When we increase the number of cells, we increase the voltage, and when we decrease the number of cells, we decrease the voltage. A simple example is a series circuit consisting of a battery, a bulb, and a switch. When the switch is closed, the bulb shines. Then we double the voltage by adding another battery. This causes the current to double, and the bulb will shine brighter. You can try this out for yourself using PhET Labs. First, set up the circuit using a battery, switch, and a light bulb. Then, make a second circuit by adding 2 batteries this time, and notice how the second bulb shines brighter. As mentioned before, increasing the number of batteries increases the voltage, the driving force of electrons around the circuit. This causes the current to increase, which is represented by a faster flow of charge in the animation. This causes more energy to be transferred to the light bulb, and so the bulb shines brighter in the second circuit. Now there is one more measurement which is important in electricity, and that is resistance. Resistance is, as it sounds, something that resists the flow of charge. Resistance and voltage work in opposition to each other. If voltage in a water pipe is like pressure, then resistance is like a blockage. Resistance occurs when electrons collide with atoms, much like how people bump into and fall over obstacles on an obstacle course. Different materials have different collision rates. For example, the collision rate of copper is much less than iron, so copper has a very low resistance. We can think of this as iron having more obstacles for electrons to overcome. These collisions cause energy loss in the circuit, as heat and sometimes even light. When resistance increases, the current will decrease. Resistance is measured in ohms. Every component in a circuit has resistance. Some objects have higher resistance than others. We call objects with low resistance, like copper and gold, and most metals, conductors. And we say that they conduct electricity. And we call objects with a high resistance, like rubber and plastics, insulators. Conductors are useful as they allow us to make wiring for circuits and transmission cables and help to reduce energy loss. Insulators can be useful too, and are often used as safety features, like the rubber casing of electrical wiring. A resistor is a component which is especially made to have a specific resistance. You can think of resistors like an obstacle course, which electrons have to complete as they pass through a circuit. Resistors are used to reduce the current in a circuit and protect circuit components.
Thank you for watching. I hope this video has helped you understand voltage, current and resistance better. If you have any feedback, please leave a comment down below.